Good day everyone. Welcome to the video lecture on the topic Standard Ethernet. Myself Vandana from Department of Computer Applications, SFA College for Women, Sivagasi. And these are the learning objective of our topic Standard Ethernet. The first objective is to explain the characteristics and frame format of Standard Ethernet. And then the second one is to elucidate the addressing scheme used in Standard Ethernet. And then to illustrate the access methods in Standard Ethernet and the implementations of Standard Ethernet. Let's watch the video. Before moving to the Standard Ethernet, let us first see what is Ethernet. In the term Ethernet, ether means cable. So, Ethernet means we are going to connecting the devices using cables. So, it is a simple and traditional technology for connecting devices in a wired LAN or WAN. So, simply saying transmitting data through cable. So, with the Ethernet, we can enable devices to communicate through protocols. This is the evolution of Ethernet. The term Ethernet was first developed in 1970s by Robert Metcalfe and David Boggs. Later, it gone through totally 4 generations. The first generation is named as Standard Ethernet, and the next is Fast Ethernet, and the third one is Gigabit Ethernet, and the last one is 10 Gigabit Ethernet. In the 4 evolutions, the difference is only on the speed. Among the 4, the first one is Standard Ethernet. The speed of the Standard Ethernet is 10 Mbps, that is 10 megabits per second. So, let us watch what is Standard Ethernet. So, first we are going to see the characteristics of Standard Ethernet. There are 2 major characteristics for Standard Ethernet. The first one is connectionless service and the second one is unreliable service. What is connectionless service means? Here there is no need for connection establishment and no need for connection termination. So, here each frame is independent of the another frame. So, each frame can choose their own route depending on the traffic and they can reach the destination. So, this is called as connectionless service. Unreliable service means here there is no guarantee for the proper and reliable delivery of the data. So, here there is the possibility for the sender to overwhelm the receiver, which may result in frame lost, but that lost too won't be known to the sender. So, if we want reliability in Standard Ethernet service means you must use TCP protocol in the transport layer. So, if the transport layer uses TCP protocol, then the lost frame will be immediately intimated to the sender that the frame you had sent is lost. But if UDP is used, then there is no provision to report that to the sender. So, the service of Standard Ethernet is unreliable. So, if you want to provide reliability in such service, in the transport layer you must use TCP, otherwise we can use UDP. First, we are going to see the frame format for Standard Ethernet. The standard number used for Standard Ethernet is IEEE 802.3. Here, there are 7 fields totally. Among them, the first 2 fields, preamble and SFD are that is formally not a part of the frame, because these are encapsulated only at the physical layer. So, it is not a formal part of the Standard Ethernet frame. And then in the remaining 5 fields, 4 fields will be treated as a header and the data field will be as data payload. So, the header field contains destination address, source address and the type, and the last is for error detection FCS. So, totally the minimum frame length is 64 bytes and the maximum frame length is 1518 bytes. So, regarding the frame length, the total number of header bytes is 6 plus 6 plus 2 plus 4 is equal to 18 bytes, that is destination address 6 bytes, source address 6 bytes, type 2 bytes and then FCS, that is error detection bytes 4 bytes. So, totally 18 bytes. So, by subtracting these 18 bytes we will get the allocated bytes for data. So, the minimum among the frame length, the minimum bytes for the data is 64 minus 18, which is equal to 46, and the maximum byte for the data is 1518 minus 18, which is 1500. So, the minimum data is 46 and the maximum data length is 1500 bytes. So, the first field, as I already said, it is not a formal part of the frame, it is only encapsulated at the physical layer. The first field, preamble, which is of 7 bytes, that is 56 bits, it is used for synchronization purpose. In this field, the value will be zeros or ones. For the first frame, the value for the preamble field will be full of zeros, and for the second frame, the preamble field value will be ones, and for the third frame once again it is 0, and for the fourth frame once again it is 1. So, like that alternatively zeros and ones will be placed in the preamble field. So, the purpose of this field is just for synchronization. And then the second field is SFD. SFD is nothing but start of the frame delimiter, which is 8 bits. Here the flag pattern 10101011 is used. It is used to indicate the start of the frame. Here the last 2 bits 11, it indicates that the field following the SFD field is a destination address. So, for this indication that is placed as 11. It is also not a formal part of the frame, it is encapsulated at the physical layer. Then regarding addresses, there are 2 addresses, one is source address, that is sender address, and the another one is destination address. Both addresses are of 6 bytes, that is 48 bits. Both addresses are called as link layer address, not IP address, as the Ethernet is worked in the data link layer, it is a link layer address. Among them, the destination address may be a unicast, multicast or broadcast. The next field is type. The type field consists of 2 bytes. It is used to indicate which upper layer protocol is used, that is in the network layer which protocol will be used. So, here the type of protocol may be IP, that is Internet Protocol, Address Resolution Protocol or OSPF protocol. So, why it is used? The purpose of this field is just for multiplexing and demultiplexing, this field is used. And then we all know that this is the field for data, and the minimum data field is 46 bytes, that is while subtracting the 18 header bytes from the 64, we will get 46 bytes, and the maximum value is 1500 bytes. For example, if my data is lesser than the 46 bytes means I will pad my data with extra zeros. That extra zeros will be removed by the upper layer. But if my data is greater than the 1500 byte means my frame must be fragmented, that is segmented. For example, if my data frame is 1518 bytes means it will be splitted as 1518 bytes, and that 18 bytes frame 0 padding will be done. Likewise, the data will be sent. The last byte, it is more crucial because it is used for error detection. So, 4 bytes are allotted for error detection. The error detection methodology called CRC, that is cyclic redundancy check, is used for error detection. And then we are going to move on to addressing in standard Ethernet. The Ethernet address is as I already said, it is a link layer address. It is also called as MAC address, medium access control address. So, the address is represented as a hexadecimal notation. As we seen in the frame format, the address field is of 6 bytes. So, there are 6 separations, each is separated by the colon. Each byte will contain the hexadecimal notation. So, for example, 4A colon, 30 colon, 10 colon, 21 colon, 10 colon, 1A. Here, what type of destination address, it will be decided by the first byte of the address. As I already said, there are 3 types of destination address: unicast address, multicast address, broadcast address. So, unicast address means single receiver, multicast address means to particular group, broadcast address means to all in the network. So, the type of address will be indicated by the least significant bit of the first byte in the address. So, if the least significant bit of first byte is 0, then it is a unicast address. If it is 1, then it is a multicast address. If all the 48 bits are 1 means it is a broadcast address. Let me explain with an example. Consider the first address is a unicast address because the first byte is 4A. In the first byte, the least significant bit is, that is 1010, that is 0. The least significant bit is 0. As it is 0, it is called as unicast address. And then regarding the second example for multicast address, 47 is the first byte. Here the least significant bit is 1, that is why it is called as broadcast address. The last example FF, all are F, that is all the 48 bits are F, that is 1, that is why it is called as broadcast address. And next we are going to study about access methods in standard Ethernet. In the standard Ethernet, the access method called CSMA or CD is used, that is carrier sense multiplexes with collision detection. What it means, before sending the data, we are going to sense the channel, whether it is busy or idle. If it is idle, we can send the data, and you must watch whether there is any collision occurred. If the channel is busy, we must wait. It is explained clearly in the diagram. Let us see first the left part of the diagram. So, whenever our packet is ready, we must check whether the channel is busy. If it is busy, we must wait. Otherwise, we can begin our transmission. After beginning our transmission too, we must predict whether the collision occurs or not. So, we must wait whether the collision occurs or not. First, we are going to check whether the collision is detected. If there is no collision detected, means transmission going on. If the collision detected, means the jamming signal will be sent. On the other side, in the jamming signal, for each jamming signal, an attempt count will be recorded. If the attempt count will be greater than 15, means then a back off time will be calculated. Back off time means waiting time. For how much time the sender can wait for the retransmission of the frame. So, if the back off time expires, means the sender can retransmit the frame, otherwise he must wait. So, why this is used means both the participants don't start the transmission at the same time. For that purpose, this back off time will be used. Then the last part of our lecture is implementations in standard Ethernet. There are 4 implementations in standard Ethernet: 10/5, 10/2, 10/T, 10/F. For each implementation, the topology differs. In first 2 bus topology, and in T star topology is used, and in F star topology is used. So, let us see clearly in a diagram. The first implementation is 10/5. So, the 10 indicates the speed 10 Mbps, and the base means baseband, that is digital transmission, baseband transmission. For that, base is used, and then 5 means 500 meter cable will be used. So, the length of the cable will be 500 meter. In the 10/5, coaxial cable will be used, and the coaxial cable is called as thick coaxial cable. So, it can't be bent. So, thick coaxial cable. For each connection, a transceiver cable will be used. So, for connecting the transceiver cable and the thick coaxial cable, transceiver is used. So, the maximum length of the cable is 500 meter, and the length between the transceiver and the node is 50 meter. Then this is the second implementation, 10/2. As usual, 10 indicates the speed, base indicates the digital transmission, and 2 indicates the meter, that is length of the wire. So, here 2 indicates 185 meter. So, here we use a thin coaxial cable, that is why we can bend the wire. So, in thick coaxial cable, it will be like a thick rod, we can't bend it. Thin coaxial cable means we can bend it, and here the connection is a T-shaped connection. So, using the T-shaped piercing method, we can connect our node to this cable. So, the maximum length of the cable is 185 meter. And regarding third implementation, T means twisted pair cable. So, using twisted pair cable, we are going to connect. So, here a new device called hub will be used. The hub will connect all the nodes, 10/T hub. So, here unshielded twisted pair cable is used, that is unshielded means unguided transmission medium. And the last one is 10/F. F means fiber optics cable. Here the hub, here too hub is used, 10/F hub. Using hub, we can connect the nodes to the internet. Here 2 fiber optics cable will be used, one for the sending and the second one for the receiving. So, that is all about the standard implement addressing, access methods and implementations. Here are some practice set questions for your self evaluation. Do try it. Thank you for watching.